All right. So this being the first class, especially after a weekend, sometimes I had to update all the Microsoft apps, so I couldn't open things up right away. So sometimes we'll have to deal with things like that. So what should have been turned in by the end of the day last night? Well, this doesn't bode well. Module 2 reading. And what else? Module 1 quiz, right? Every week, I have to reiterate this last week, both classes, there's going to be a quiz due at the end of the day Monday, as well as the next module's reading. Now, these readings, I understand they might seem kind of trivial. The questions are somewhat easy, a little bit easier. It's a way I said to what? Prime your brain for what we're going to talk about. It's also, to be completely honest, a way for you guys to earn easy points, right? So sometimes I do things for learning objectives that I think are going to help really learn. I think that the top hats do help because it primes us for what we're going to talk about the next week, but it's also a way for me to give you effort points, right? Simply getting on and getting those done, okay? So next Monday, right, what is going to be due? Yeah, a module 2 quiz and the module reading for chapter or module 3, right? The next, so it's going to continue to do that throughout the rest of the semester, okay? So you'll see kind of the module 2 stuff that's already up there. That module 3 reading, I'll kind of get probably thrown up after class on Thursday. So I generally don't make them due until we've covered the previous modules material. So those module 3 readings and those quizzes pop up after class on Thursday. All the module 2 materials. I've got some additional files we might look through. I don't think we'll get to them today, probably on Thursday. But you've got the skeleton version of the slides, the kind of outline that has the learning objectives. I've already got the practice problems up there. Now this week, this is being a little slow, so hopefully this will pop up. There we go. This week, there will be CL sessions. So I think I've got them all kind of assigned to my UGIs, my undergraduates. I've got the locations, the times. I have a file kind of ready to go. So here's kind of the learning objectives for the week. I will throw up that CL file under module 2. It's basically going to be an Excel file that's sortable by name. So you can find your name, and then next to your name, it'll have your assigned day and time. That'll submit a way for me to guarantee that you'll have a slot. But really, you can attend any day and time that works for you week to week. You can change week to week. You'll still get your attendance recorded. It's more of like if you really don't want to pay attention to it, you really don't have to. It's just a way for me to kind of have a guarantee that you have a slot. And based off everyone's preferences, I was able to get everyone in there first preference, right? So whatever you responded to that collaborative learning poll with, that's the time slot essentially I assigned it to, right? Now, like I said, that's not, if for whatever reason this week something comes up and you answered Thursday and you have to go to Sundays, that's fine. They're looking at the list, there's going to be available seats at every single day and time location, right? So it's not a big deal, but you will see that pop up when I get back to my office after I get done teaching here this section, my next section, okay? Other than that, I'm trying to think of any other housekeeping stuff. So that those CL sessions, they'll go through these practice problems. They have a more in-depth kind of solution file that they'll kind of work through with you. I might have thrown in some additional things there, like some additional questions to think about that they could kind of, oh, well, what if this question changed to this? What would the answer be? And kind of a little bit more in detailed, descriptions or solutions there that they'll have when you attend those, okay? And I won't make those available. Those are only available through the CL session leaders, okay? And we'll talk a little more about those Thursday, just to kind of hammer down once you get there, how do you sign in? You sign at the end, they'll kind of, record your attendance to earn those. Really the only way you can earn extra credit in this class, okay? Like I said, it was 0.25% every week you attend one, total of 3% at the end of the semester. Might not seem like much, enough to kind of change your grade if you're on that threshold, anywhere close to the threshold, right? 3% would definitely bump you up to that next level grade, okay? Any questions from me before we get jumping into material here? So I'll generally kind of do this like recap or a little bit of like housekeeping, what I call it, stuff before we jump into material every day. Okay, everybody stay warm this morning? Warm enough? So the other thing I will mention, I got a couple emails. Those module readings, I think this will also apply to the packback, although I think they somewhat sync every, I forget how many hours. They may not pop up right away on Canvas. So even though it is synced up, it's synced up after the due date. So as long as you can see that you've submitted it and you've answered the questions on Top Hat, it will get uploaded to Canvas after the due date, but it's not going to happen immediately. Okay. I'll play around. I looked at it, and from my knowledge, there's not a way I can do that unless I manually like go in every few hours and update it. But that's not great either, because then if you haven't done it, it shows up like as a 0. So I'll talk with the reps, see if there's a way around that, because I understand the panic of like, I think I have it, but it's not showing up on Canvas. Know that if you can see that you answer those questions on Top Hat, it'll always get synced up to Canvas once that due date passes. Okay. All right. Any questions from me before we dive into material here? We'll have a little bit more material than we did last week, so the questions might start getting a little bit harder. So if you have any questions at any point in time, make sure you slow me down, stop me. All right. I might think some of this stuff is easy, but like I've done this a lot. So I try to keep that in mind. But if you ever have any questions, throw your hand up real quick. Okay. All right. So what we're going to start talking out in here, this is probably one of the most macroeconomic concepts or topics we cover the whole semester, which is kind of weird. We start out with it, and then we kind of go back towards more microeconomics. But this also would apply to a lot of our microeconomic models, which is why we cover it. Yeah. So if you're on Canvas, right, module 2, you should be able to see them. Everyone seeing these there? No? Why would these not be shown up to you? Let me try to manually republish everything. So they're locked. Let me see. Thank you for asking that. Oh, that's why. They're supposed to upload there. So let's see. Try refreshing now. Let me know if that works. Did that work? Thank you for saying something. I'll try to be a little more on top of them. When I upload them, they're supposed to upload as automatically published. I might have hid those last week and forgot to kind of switch them over. Okay. So you've got those skeleton slides. That's what we'll start working through. Okay, so if you want to pull it. Also, we'll use some questions later on in class. I'd like to use Top Hat, so try to get that pulled open. We'll see if we can get that to work today. We all have it ready to go. Once I use it, maybe the Wi-Fi won't be as big of an issue. If not, also have Canvas pulled out open. I've got a kind of backup quiz sitting here on Canvas. In fact, that's the one that I don't want you to be able to see. So I'll unpublish those, and we'll worry about those when we get there. Oh, now it's not liking this. Someone must have already entered in this, and well, I'll worry about this one later, right? So we might have to kind of resort to using this one later on in the class. What, did someone already access this? That's why. Yeah, someone already. Okay, well, I might have to delete that for next class, so it's not a big deal. So let's just, I don't really want to remove it. I'll worry about that after class, never mind. So let's jump into material. So we should have the slides now available to us on Canvas. We'll start out with what we call these production possibility curves, or sometimes you'll see them called the production possibilities frontier. So PPF, PPC. I'll generally use PPC. I might slip into saying the production possibilities frontier here and there. Those two terms are synonymous. So let's start out assuming we have an economy, and you can think of us even could be at the firm level, but we'll do an economy level here. And this kind of seems trivial, but for now, we can produce technology goods. I chose computers or produce, right? Agricultural products. So we kind of have these two very different goods, right? We've got a certain number of resources in our economy. I'm going to call these just labor hours. So we're simplifying things here. We're assuming that it only takes one resource to produce these goods. Obviously, we need like raw materials. We would need, I don't know, whatever metal products we need to produce computers, things like that. But we're going to simplify and say it just takes man hours. We've got all the other resources available. We just have a limited resource of labor hours. Okay, we only have so many people. Excuse me. So let's assume that every computer is going to take 100 labor hours, and every, I don't know, ton of wheat here is going to require 10. Right. So if I have 50,000 labor hours, each computer costs me 100 labor hours. How many total computers, if I put all of my labor towards producing computers, how many could I produce? How would I find that? Yeah, how'd you get that? You took the total number of labor hours, 50,000. Each computer costs you 100, so 50,000 over 100 would give you that 500, right? What if I wanted to only produce wheat here? Yeah, I've got 50,000 labor hours. Each ton of wheat cost me 10. So 50,000 over 10 would give me, excuse me, that 5,000. So we can kind of think about the extreme points, right? I'm putting all my labor hours towards computers. I end up with 500. We'll gloss over these for a second. If I'm putting all of my labor hours towards wheat, I can get 5,000. So those are kind of my extreme points. Now, there's any combination of points in between. For most of these models, it's probably going to be easiest to just use these extreme outliers. And then we can kind of put this in graph form, right? So with this in mind, how am I going to draw out this production possibilities curve? There we go. Let me make sure I want to line this up with, well, I guess it doesn't matter for right now. We'll make the math a little bit easier. Let's grab these Sharpies. So either this is just struggling to work, or got a bad batch. Let's hope it's not the bad batch. There we go. So let's do quantity of computers down here and the quantity of wheat up here. Okay. We said if we were only producing computers, how many total could we produce? Well, 500 computers, 0 tons of wheat. What if we were only producing wheat? We had what? 5,000 tons of wheat, 0 computers, right? So we have kind of the two extreme points. Our production possibilities curve for right now, right, when we're looking at it like each country or each individual, is just going to be a straight line in between those 2 points. Okay. Now, there are going to be other points on this curve. For instance, if you look at the slides, one of the points I had there was what? 104,000, right? Right. Now, how did I come up with that? Well, we can kind of think about, if I wanted to go from producing no computers at all to producing 100, right? How much did each computer cost me? I said it costs us how many labor hours? 100. So what's the total cost if I want to produce 100 computers? 100 times 100, right? Or, oh, that's not going to be, right? 10,000, right? So that was the total number of, and when I say the cost of, this was in terms of how many labor hours it was going to cost me. So if I had to take 10,000 labor hours and put it towards computer production, what am I no longer putting that towards? We had a simplifying assumption. We were only producing 2 goods. So if I want to produce more computers, I have to produce fewer tons of wheat. We only had 50,000 labor hours. Before, we were using all of them to produce wheat. So I now have to give up 10,000 labor hours towards wheat production, put it towards computers. So how many fewer tons of wheat can I produce? Well, each ton of wheat cost me what? 10 labor hours. So I was going to have to give up 1,000 tons of wheat, which is why the point on that curve would be 100 computers, give up 1,000, I'd be at 4,000 tons of wheat. Now, I could really come up with any point on this curve, right, by doing this same process. There's usually no reason to like find every single point. Once again, if I find the extremes, we'll end up finding a way here in a second where I can find something else related to this curve that makes it a lot easier to find any point on this curve that I want to. Okay? But for now, just kind of giving this general idea, this production possibilities curve is representing, here's all the possible combinations of these 2 goods I could make using all of my limited resource, or in this case, all of my labor hours. That was the only limited resource we had. Okay. Any questions on this idea before we keep moving here? Is this kind of making sense here? So what does this line up with what we talked about last week? To produce more of one good, there exists I think someone said it, starts with a T. If I do something, I have to give up something else. That's like a trade-off. Or we can kind of think about what exists when I want to produce more of a good. It has an opportunity cost, right? What is the cost in terms of the other good? If I want to produce more computers here, my economy can't produce as much wheat, right? So I've got this opportunity cost Let's think a little bit harder about that. Okay. So once again, these slides, like I'll leave blank slides when I draw stuff a lot of the time. Right. So if you're like, oh, what do I do here? There's never going to be anything else here other than what I drew. Right. That's the part of that's why coming to class is important. Okay. So if we're thinking about this trade-off that exists or these opportunity costs that exist, how do we come up with, okay, well, I know I had to give up some wheat, but how much? How much wheat was each computer costing me? Okay. So remember, what we give up is our next best alternative. In these simplified models, we only had 2 goods, so it's pretty easy to identify. The only other thing we could produce was our next best alternative. In a very complicated model, you could say, well, I could produce 3 goods, and then we could have like this 3-dimensional production possibilities curve, and then 4 goods. It's a 4-dimensional thing we can't even visualize, and then it becomes the math, matrix algebra, things like that. We're not going there. We're keeping it at 2 goods, right? Nice 2-dimensional graphs that we can actually get a good visual of, okay? But the same principles would apply. So what'll end up being the case is if I want to know the opportunity cost or the cost of the x-axis good, so whatever good I put on that x-axis, the slope of my production possibilities curve will tell me the cost of that x-axis good in terms of the other good. Okay. So we can kind of prove this to ourselves here in just a second. But for now, take me at my word. Right. So the slope, now I have to be a little careful here. The slope of this production possibilities curve, because this trade-off exists, it's always going to be what? Negative. Negative. So technically the cost, we don't talk about costs like, oh, it's negative this. It just is what it is. So that's why it's the slope, but we get rid of that negative sign. So negative times negative, we get rid of our negative sign there. If you want to think about it in an easier way, the absolute value of your slope, just ignoring the negative, that will be your opportunity cost of the x-axis good. Okay. If you want to get the cost of your y-axis good, well, we'll see how much time we have, but you could just redraw this and move the 2 goods on different axes, right, and then calculate the slope. We don't have to redraw it every single time. Once you find the slope, that tells you the cost of your x-axis good. What will end up being the case is the cost of your y-axis good will always be the inverse of that, or 1 over that value. So the cost of our y-axis good will always be negative 1 over the slope, right? Same kind of idea, 1 over the slope in absolute terms, okay? And I'll prove this to you here with those numbers we were using here in just a second. So if we go back to our example, what was our slope? Well, we hadn't calculated it yet, so let me go ahead and do this. I'll use a different color to kind of indicate we're working on like a different problem here. Also, you guys can't probably see that. Let me see. Is that harder to see? Or is that easier? That one's better? Is that one better? Or that one? I feel like an eye doctor here. This one? Okay, all right, we'll keep it on this then. All right, so how would I find the slope of this line? If I have the 2 extreme points, how do you find a slope? It's just the change in y over your change in x, right? So what was the change going from these 2 points in my y value? I was going from 5,000 to 0, right? So the change there, I went from, the new value is 0, the old value is 5,000. What was the change in my x value? I was going from 0 to 500, right? So here I end up with a slope of negative 10. So this slope, I said, should represent the cost of one computer in terms of my other good, right? So every computer is going to cost me 10 tons of wheat. Right? I can think about why that's the case, right? Well, if I do a similar thought process here, in terms of labor hours, what's the cost of one more computer? Well, each computer is going to cost me how many labor hours? We said 100. How much was each ton of wheat costing me? 10. So how many times does 10 go into 100? 10. So the total cost in labor hours was 100. That meant that I was going to have to give up 10 tons of wheat there. That's kind of where that cost comes from. Now you don't have to go through this every single time. I think it's probably easier just to like draw out your production possibilities curve and just use these two extreme points to find the slope. That'll tell you the cost. Now, the cost is always in terms of, I put -10 here, but -10 what? It's what I'm giving up. So it's going to cost me 10, whatever that y-axis good is, right? 10 tons of wheat here. Okay. Everybody with me to this point? Any questions here? What if I wanted to know if I can spell, what's the cost of 1 ton of wheat? Well, I said the slope of this curve will be the cost of my x-axis good, or the absolute value of that slope, right? So the slope was -10. The cost of one more computer was 10 tons of wheat. What's the cost of one more ton of wheat going to be? We said that should just be 1 over my slope, or 1 over 10, or in absolute terms, right? Technically, the slope is negative. We said we're ignoring that negative sign. Costs are always inherently, right? Saying that it's a cost implies that it's negative, right? So what are we giving up to produce one more ton of wheat? 1/10 of a computer, right? Or personal computer, however you want to notate this. Okay? Now, I can prove this to myself. Let's see. Can I keep this all on the same thing for us here? Maybe. There we go. Let's say instead I had drawn this out and I just flipped it and put what I wanted to know the cost of. So I put wheat on my x-axis now and computers on the y-axis. Well, if I'm only producing computers, I can produce 500. Only producing wheat, 5,000. Now my production possibilities curve, right, would just be a line between the two. What would the slope of this curve be? Well, the change in y was, I'm going from 500 to 0. Change in x, I'm going from 0 to 5,000. So this would end up being -1/10, which is exactly what we found if we just drew it out once and then said, oh yeah, the cost of the y-axis good will always be 1 over the slope. So whatever's easier to, if you really wanted to, you could draw both of them every single time and just always remember, oh yeah, the cost of whatever I put on that x-axis, that slope represents the cost of that x-axis good. And to get the cost of the y-axis good, I would just do 1 over that slope. So notice, if I wanted the cost of a computer here, so this was cost of 1 more ton of wheat. Now that computers are on my y-axis, the cost should be 1 over the slope. So 1 over 1/10 would end up being 10, which is exactly what we found before. Now, once again, there's a negative sign because it's downward sloping. We're talking about this in terms of cost. We're always inherently just taking the absolute value and ignoring that negative sign. Any questions? I know I did this a little bit, but hopefully it's just different ways sometimes of looking at the same thing. Hopefully some things might click with some people better than others. Okay. Say that again. So if you're ever asked for the opportunity cost, I'm not going to try to trick you. I'll give you responses that are all positive. Right? We're talking about it in terms of a cost, so we know inherently that it is a negative value, right? We're giving something up. Yeah, but I'm not going to try to trick you with like the calculation. Yep. Yeah, if I ever ask you like on the quiz this week, even if it's like a numerical response one, I'd probably throw in there to accept either answer, but just default to always think, just give me the positive value, right? We're ignoring that negative sign. We know that inherently we're talking about costs. There's always this negative value there. Yes, you hear me okay in the back, by the way? Am I loud enough? Okay. I do take time. I do want to be better. So I read through my OCQs from last semester. I was in a different room and I saw 1 or 2 like use a microphone. I think that I speak pretty loudly, but if I ever start to trail off and you can't hear me, let me know because I have microphones. It's just that honestly, I talk loud enough to where sometimes I feel like that's even more of a distraction. It gets too loud, right? Okay. And if you don't know what OCQs are, those are like the survey things you guys fill out. So I'm using a little bit of inside terminology there. So any other questions on on finding the cost using these slopes here before we keep moving. Okay. All right. I think this should give us a pretty good background to start thinking about other things. So we kind of worked through all this example. Let me keep an eye on time. Okay. So we can do this like at a country level. So that was like my example for one country. It could have also been like one firm. Problem is, different countries are at different levels of development. For the US to produce one more computer, it might be a lot less costly than it might cost, oh, I don't know, a country that isn't as economically developed, right? And so we know that costs vary. So we'll kind of set up now an example, not thinking about countries, but we'll even go more of a micro level, right? And think about who do we want in our economy? Who do we want producing certain goods? Well, ultimately, if I could choose, I'm looking at all my resources in my economy. Who do I want producing the first unit of a good? Whoever can produce it at the lowest cost, right? I don't want to rely on the person who is taking all their labor hours, right? Maybe I want to rely on someone who's really good at that one specific thing. So I've got this example set up. Maybe the CEO of Ford, he has somewhat of a background of automotive knowledge. And so he can fix or she can fix their own car in an hour. We've got a mechanic, they can fix the car, right, in 3 hours. Right? So maybe this CEO is like exceptionally good at working on cars for whatever reason. Right? Let's run with this example. So we've got two individuals. We think about just in terms of the time cost. The CEO of Ford is a little bit better at, fixing their own car. So why would they rely on the mechanic to fix it? What is that 1 hour? CEO of Ford, we said that 1 hour would be what? Yeah, what's true about that 1 hour for the CEO? It is worth a lot of money, right? The mechanic, their time, right, might not be as valuable. So we can think about, let's say we put the time of a CEO, we value it at $2,500 an hour, right? If he was taking that same hour, devoting it towards working on, I don't know, things that CEOs do, right? That we would value it at $2,500, okay? So should they still fix their own car? Well, it's going to be pretty costly, right? Just paying the mechanic, what, $200 for the 3 hour? It's going to be a lot less costly than giving up $2,500, which is the value of their time if they were to take that hour, not fix their car and do something else. So we can start to think about what this is going to look like. So in terms of our CEO and our mechanic example, who would we say has an absolute advantage in fixing this car? So an absolute advantage just means that using my resources, my available resources, I can produce this good. The weird one, like the good is like fixing the car. I can produce this good at a lower, right? It takes me fewer resources. So in this example, who uses fewer resources, fewer labor hours? The CEO. Is that right? Yeah. So the CEO might have an absolute advantage. They're using fewer of their resources. Here, we've only looked at the resource of time, right? Just having one resource to keep it simple. So absolute advantage is I can produce this good just at a lower amount of that resource, right? So a little more textbook definition, right? If I can produce more of a good and it costs me lower amount of resources, I have the absolute advantage.
Wouldn't you have to include marginal benefit though, because you said the CEO is like exceptionally good at fixing cars?
Yeah, so we've got another terminology, right? So we would say the CEO has an absolute advantage, but who has the comparative advantage, right? So the comparative advantage factors in that just because I can do it in a lower amount of time, if my time is more costly, that's not better off for society. So what factors that in? That would be our comparative advantage. Comparative advantage says, who can produce this good, or in our example, who can do this activity at a lower cost, right? Because yes, it only costs the CEO 1 hour, but we really haven't calculated the total cost yet, right? Because the total cost would be the number of hours times how much each hour is worth. So if we think about, in our example, if we're taking, say, 3 hours to fix that car, right? Even though it's taking the mechanic more hours, what's the total cost? he's charging 200, it must have cost, like, he would be willing to accept up to whatever his cost is, his marginal benefit, as long as it's greater than or equal to his marginal cost. So $200 would be their cost. If the CEO does it, yeah, it only took him an hour, but what was his cost? 2,500. So if we relied on the CEO, that's not the lower cost. They would not have a comparative advantage, right? The comparative advantage, oh, there we go, is whoever can do this activity, produce this good at a lower total cost. So we're not just looking at the number of hours, we're taking the number of hours multiplied by how much each hour is worth, really calculating the total cost of producing that good, or in this case, fixing the car. Okay, so two different terms. I'll put this in the context of more of the type of questions you would see this in, but absolute and comparative advantage do not always line up. This is a good example of which the CEO had an absolute advantage, but not a comparative advantage. Right? So let's think about this instead. I've once again show some goofy goods, but not really that goofy. We're thinking about maybe I've got two countries and they're producing two products, right? iPhones and aircraft parts, right? Whatever it is. It's similar materials, I don't know, metals and other things. And they've got labor. Here, we're really going to focus on that. We're putting labor hours towards the production of these different goods. So usually I'll give you something that looks like this. Right? Now you could see it in word form as well, but this is kind of a nice, quick way of getting information out there that if I'm using all of my resources, and I'm in the United States, I can produce 60 iPhones. These numbers aren't completely realistic. I'm giving you some easy numbers to work with for the math here starting out, right? If they're putting all of their resources towards aircraft parts, they can produce 30. Same kind of idea. If India is putting all of their resources towards iPhone production, we can get 50. If they're putting all of their resources towards aircraft parts, we can only get 10. Okay. So if I'm looking at this, just from this information, absolute advantages are very easy to identify. Who has an absolute advantage in iPhone production here? The US. Who has an absolute advantage in aircraft part production? So we have examples like this. The same person can have an absolute advantage in producing both goods. We see this play out. I mean, you know, not to like, the US is not like the best country in the world. So I'm just using them as an example. But there's a lot of countries like the US around the world that they probably, compared to other countries, have absolute advantages in a lot of the production of a lot of different goods. Now, why don't they produce, you know, why doesn't the US say produce as much textiles or clothing? Well, just because they have an absolute advantage, that means they're putting the resources towards textile production and not towards more technologically advanced goods, which means their cost, right, might be higher. We haven't talked about comparative advantages yet. So absolute advantage, just I can produce using all of my resources, more of this good, okay? So here we've got an example where the same person or country has an absolute advantage in both goods. Everybody with me? Now, once again, this is a good time to point out, and it's early in the semester, so I'm trying to build good habits. I just said some things that if I were you, I might be writing down that don't pop up here. They might pop up on a future slide. I can't always remember exactly what I put in the slides later on. But what did I just say that isn't on this slide? The US has an absolute advantage in the production of both of these goods. Right? That's something that's not up here, but we just talked about it. Right? So maybe as you're going back to your notes, it might be a good thing to, you know, oh yeah, that's what we were talking about there. Okay, so what we can do is then draw out a production possibilities curve for both of these individuals, and it will help us identify who has a comparative advantage. Now, you don't have to draw this out graphically, but it'll help us. Some of the questions you'll see, you might get a graph, and I'll kind of work through both, drawing it out for you so you have a nice visual in graph form, or just using the table. So what we're going to do is draw out each country's production possibilities curve here. Okay? So that's what I've got right here. Okay? All I did was say, if I'm the US, try to keep them yellow, if I'm only producing iPhones, I can produce 60. So 60 iPhones, 0 aircraft parts. If I'm only producing aircraft parts, we said the US could produce 30, which means they're producing now 0 iPhones. And then I did the exact same thing for India here. Okay? Now, I tried to, well, I know I drew this out, excuse me, to scale because I used Excel, so I kind of cheated. So if you're drawing this out by hand, this might get a little bit trickier. But if I were to, you know, actually draw this out to scale, which of these countries has a flatter slope to their production possibilities curve? India. What is the cost of my x-axis good? We said that was the slope. So if their slope is flatter, that means the value, when we calculate the slope, will be closer to, which means India has a lower opportunity cost of the x-axis good. Okay. So here, if I wanted to calculate this, now if I was doing this, I would first use black instead of blue. So let's do, we had iPhones, I think, here, and then aircraft parts, right? I would probably draw this out on separate graphs. You can put it all in the same one. So here I'm just going to do, okay, what did the US's look like? Because when I'm drawing this out, just looking at the numbers, I could accidentally draw one slope flatter or steeper if I just look at the numbers wrong. So we actually want to calculate the values to make sure that we aren't just relying on like the visual, right? So what would the cost of an iPhone to the US be, right? Well, it's the slope of this line, right? The cost of our x-axis good. So that cost would be what? Change in y would be -30. Change in x, we're going from 0 to 60. We said we can like take the absolute value or ignore the negative sign. So we get, this is going to be what? 1/2 of an aircraft part. Okay. Now we could do the exact same thing. Once again, I don't like to draw on the same graph just because I'm not good at looking at values and drawing the scale all the time. So I just want to make sure I'm doing it correctly. So here, like, let's say, for instance, let's say I drew it wrong. So this is not to scale. And I'm like, oh, India's got a steeper production possibilities curve. Their opportunity cost must be higher. Okay, well, maybe you just didn't draw it correctly, right? But if you use the actual numbers, it doesn't matter how you draw it, right? Because here, what would the cost of one more iPhone to India be? The change in Y would be -10. Change in X would be 50. Absolute value, you could do 1/5. If it helps here, 1/2 is 0.5. This would be 0.2. Who has a comparative advantage in iPhone production? Who can do it at a lower cost? 0.2 is lower than 0.5. So we would say India has the comparative advantage in iPhone production here. Everybody with me up to this point? So once again, you can draw them on the same graph and calculate the slope. That's fine, especially if you like graph paper. Then you might make sure you are drawing to scale. It might be a little better. But like on the exam, I don't give you graph paper, it's blank paper. So I would maybe draw them out separately just to kind of keep everything, you know, make sure you're doing it correctly. Okay. Now, what I could also do at this point is not just find who has a comparative advantage in the x-axis good. Instead of drawing this all out, flipping, right? Maybe I want to know who has a comparative advantage. Excuse me, not in iPhone production, but aircraft part production. Well, I could redraw every graph, put aircraft parts in the x-axis, go through the whole thing again. Or notice here, what's the cost of an aircraft part for the US? And down here, I could do what's the cost of an aircraft part for India. So how do I find the cost of the y-axis good? We said it was just 1 over what? Slope. So here, this would be what? 1 over 0.5, right? So this is 2. Now, what's the cost of an aircraft part? To what? Whatever the other good is. So I'd have to be giving up the production of 2 iPhones. What about for India? Same idea, 1 over the slope, or what would the slope represent? The cost of my x-axis good. So here it'd be what? 1 over 0.2, or it would cost India 5 iPhones. So who has a comparative advantage in aircraft part production? Who can do it at a lower cost? So we would have comparative advantage for the US in iPhone production, and we had comparative advantage for India for sorry, I might have said that backwards. Comparative advantage for the US for aircraft part production, comparative advantage for India for iPhone production. Now, you can go through and calculate this every single time and prove this to yourself. But once I identify who has the comparative advantage in one thing, automatically in these simple two good models, the other person, other country, other firm, other individual has to have a comparative advantage in production of the other good. So for those of you who are a little bit math minded, this might be a little bit above and beyond, but like, for instance, if X is less than Y, right? In this case, what did we have? We originally started out with 0.2 and 0.5. Anytime I take the inverse, what happens to this sign? Flips, right? So notice when I do 1 over this, we ended up with what? Oh, what did I have here? So this was 2 and 5, right? So that'll always be the case. It's a rule of mathematics. Because we calculate the cost of the other good by 1 over that slope, anytime the cost of the x-axis good is lower for one country, the cost of the y-axis good will automatically get higher, right? So once we identify who has a comparative advantage in one good, we don't even really have to go through the math. We automatically know the other person has a comparative advantage in the other good. So if I ever ask you for an example, if I ever ask you a question, like for an example like this, and I say, who has a comparative advantage in iPhone production and aircraft? Maybe you identified the wrong country, but there should always be 2 different countries there. It should never be US, India, India, right? It should always be one country can only have a comparative advantage in one of those goods. Now, when it came to absolute advantages, we said a country can have absolute advantage in both goods or neither, right? But when it comes to comparative advantages, because of the law of mathematics and the way that we're calculating these costs, inherently, if I have a comparative advantage in one good, the other person has to have the comparative advantage in the other good. Any questions? Once again, so I put this in red. If this is a little bit confused, this is more of like the reason why. You don't necessarily have to know this or work through this every single time, but that's why we get to that result. So there'll be some things in this class I like to work through. I don't just like to tell you guys things, or I have to give you some of the support behind why. We don't always have to have like the perfect understanding of the support behind why. In this case, if you just want to remember the outcome of the math, the outcome is that each country can only have a comparative advantage in one of those goods production. Okay? Or in the production of one of those goods. I'm not an English major. I'll try to say things a little better here. Okay? So I wouldn't give you an example like that, but it's theoretically possible, right? So I guess in theory, there is an example where in that model, so let's say we have the same cost for the x-axis good. What would be true about our cost for the y-axis good? They would also be the same, in which case we would say like, nobody has a, like, it really doesn't matter who produces it, right? We both are producing it at the same exact cost, who cares? I won't give you one, those aren't the most interesting models. And honestly, to be exactly the same cost in the real world, probably not very realistic, right? But in theory, you're right. We could end up with a point where each person has the exact same cost. Yeah. Any other questions? Yeah. No, so when we're talking about comparative advantage, we're strictly talking about can they produce one of this good at a lower cost or not? Yep. Now, when it comes to things like actual trade, it's going to matter that, yeah, even if they have a lower cost, they're going to deplete their resources pretty quickly, right? But in terms of when we're thinking about, and we'll get to it here in a second, I don't know, we might not get to it completely today. I think we might have enough time to work through it. We're talking about things like trade. Well, we would still see them trade. It's just that the volume of trade wouldn't be very high because that country doesn't have, even if they have a comparative advantage, they can only produce a small number of that good. So we won't like dive into like the volume of trade in this class, but that would be the next thing. Once we know that they can trade because their costs vary, well, then what would the volume of trade look like? But well, we're not going to talk about volume. We're just going to talk about identifying if they do have varying costs, could we see them trade? We're not talking about how much they would trade. We're just saying what that terms of trade would be. That's eventually where we'll get to. Does that answer your question? Any other questions here before we keep moving? Okay. So I went through a little bit of this, so we'll kind of go through these slides probably a little bit quicker. Because we already calculated this, right? So sometimes I'll even have things in the slide. I like to like build it out a little bit more if we have time on the dot cam. So we identified, what the opportunity cost of this x-axis good was for both countries. We said who had the lower cost for iPhone production, or who had the smaller or smaller cost, lower, flatter slope. That was India, right? Then inherently, we said they're going to have the comparative advantage. So if we wanted to look at then the comparative advantage of the other good, well, the cost of the other good was 1 over that slope, or 1 over the cost of the x-axis good. So that gave us these values, in which case we said, when it comes to aircraft part production, who has the lower cost here? That would be the US. So we identified India has a comparative advantage in iPhone production. Inherently, even if we didn't calculate these values, that means the US has to have the comparative advantage in the other good, or comparative advantage in aircraft part production. Okay. Any questions on this? Okay. All right, I'm going to skip through this. Where are we at in time? Well, we'll save this, and if we run out of time, we'll kind of finish the next class, but I think we can get to about slide 19 here. So let's try. Let's see if we can get Top Hat to work today. I probably won't have a lot of patience with it. We'll give it a couple minutes here. Again, mentioned try to have this pulled up at the beginning of class. Also Canvas. If this doesn't work and we have too many people not able to get on the Wi-Fi, we'll kind of pivot to Canvas here. So let's say you got Top Hat pulled open. I think it'll prompt you for the join code. It's always going to be the same, 666213. Right. So once you get that, should pop up on your device. So let's say question 1 here. I'll talk through this example, right? I'll kind of wait for you guys to kind of get in. So sometimes I'll be friendly like this. I might not even have you work on it, especially the first question. Some of you know you're still trying to get logged in. See, once I get done explaining this, where we're at in terms of the Wi-Fi here, and then we'll kind of go from there. So I would do something like this. So it looks like we've got 170 people almost in right now. But if I'm looking at a production possibilities curve or production possibilities frontier, so this is somewhere where I use that interchangeably. If I'm using all of my resources just to produce guns, and I gave you this visual, so this is like an age-old example in economics, like thinking about economies. You can produce things that feed your people or protect, right? So guns and butter was like the age-old example. So here, if I'm only producing guns, how many total could I produce? Yeah, all I do is go to that extreme point where I'm producing 0 units, whatever the units tons of butter is. I'm only producing guns. I can produce 600 total. Right? So these extreme points, if we don't have that little like 2x2 matrix that told us if I'm using all my resources, how much could each country produce of this good, I could get that same information from production possibilities curve graph. Whatever country this is, country A, we'll call it. If they're only producing guns, they can produce 600. If they're only producing butter, they can produce 800. Okay. So at this point, I'll kind of ask, how many of us are getting a spinning wheel of death on Top Hat? Good amount. So we're going to pivot. So if you answered this, don't worry. Let's go to Canvas and see if we can get this to work. Okay. So once again, people already started accessing this before we even got going here. Well, it'll take me some time to recreate this, but I'm just going to remove this just to make it easier. So I'm going to set this to be released. So manually open this. We now have this class participation 1-21. I'm going to just preview it. All right. So you should see this quiz now sitting on Canvas, right? I think I have it set to be due at 9 and 10 minutes. I can change that here if I want to. But you should be able to open this up on your Canvas account, right? You should then have, you can start it. And I think I have it set, so if I didn't, you might see, yeah, it looks like here I can see all 3. And you would kind of have these 3 questions, and I might have you kind of respond to these, work with the people around you, and say, you know, this quiz, we're going to close it out here in 5 minutes, or 10 minutes, right? So work with the people around you, try to come up with answers to these questions. And this would be how we kind of use these in-class quizzes. Oh, hold on. I can't hear you. 121. Hold on. All right. So it's published. So try to refresh. If you had Canvas open, try to refresh. Is it, see it popping up there now? Yep. All right. So how many people can not get this to open up on their device? We're getting a small handful. What is it showing you guys? Is it just loading? So you can get it to upload on your phone. So let me think. Let's give it another minute and see it. So those of you who aren't able to access it, is it just like taking time to load? Like, is it just showing that it's still trying to load it up? Okay. How do I want to do this? Why, if I shouldn't give us issues with Canvas? Well, we'll leave it open and see how many of us we can get in over the next 5 minutes as we kind of just talk through these together. Okay. And if you're not able to get in by the end, I'll talk about it. But yeah. Yeah. So Top Hat didn't work. I had like 30, 40 people, more than 30. I had 40 people not. So let's see if we can get everyone here, even if it takes a couple minutes. So these are the types of questions that I would ask you. So we already worked through this one on Canvas. So we should hopefully know the answer to this one would be 600 total guns. Now, what if I want to know the opportunity cost of 1 more unit of butter? So this is where having this pulled open in front of you is going to be a little bit easier to see. Sometimes these images might be a little bit smaller. How would I find the opportunity cost of 1 more unit of butter here? What butter is on what axis? So all I have to do is find my, how would I find the slope here? What are the 2 extreme points? 600 and 0, 800 and 0, right? So what's the change in y? So if I move from that point to this point, what's the change in y? It's going from 600 to 0. So the change is 600 or negative 600. If I'm going from that point to that point, the x value is going from 0 to, so the change in x is, so change in y is 600 divided by my change in x, which was 800. I should have a slope of 0.75 or 3/4, right? So the slope of my production possibilities curve tells me the opportunity cost of my x-axis good, right? So what is the cost or opportunity cost of 1 more of the x-axis good? If I'm putting a number in here, what should I put in here? 0.75. Now, this one, I just was looking for a value. Really, if I had like a multiple choice question set up here, it would be 0.75 what? The other good, right? I'm giving up 3/4 of whatever the other good was. Well, if I'm talking about the cost of the x-axis good, what I'm giving up is whatever's on my y-axis. So here it would be 0.75 guns. Now you have to type guns in here. We're just looking for the number here, right? But if I were to give you kind of a multiple choice where some of the answers had guns, some had butter, you have to remember what you're giving up is the other good. Okay. Any questions on this one before we keep moving here? Okay. All right. So at this point, how many of us are still not able to access the quiz? Anybody? Everybody got in? All right. Hold on. Let's be quiet for just a second. I just want to triple check. Everybody was able to get in and respond to this quiz, correct? So nobody, I'm assuming everyone got in. Perfect. So I think these Canvas quizzes will work, especially if we don't pull up from Top Hat first. I think that pulled some of the Wi-Fi probably initially, so it should be a little bit less clunky getting into these Canvas quizzes. From here on out, I'm not even going to try to use Top Hat for quizzes. We'll just use Canvas. Generally, I'll give you like a little bit more of a time block. We won't talk through the questions. I'll have you work with the people around you. You will actually have to try to get them correct. Now, here, we didn't quite get to question 3 today. Don't worry about that. Just make sure for question 1, we've answered with 600 So this is where if you're here in class today, you have a pulse and you're paying any amount of attention right now, you should be able to get all the points. So 600 and then 0.75 and then answer whatever you want. Actually, yeah, answer whatever you want for question 3. Initially, these might upload and not show you having full points. I'll just go in manually. As long as I can see you respond to the first 2 questions, I'll just re-upload it and kind of give everybody credit that was here and responded today. So you'll basically, for just being here today and responding to those first 2 questions, everyone should get those 2 right. So we just said what the answer should be. What should the answers be to the first 2 questions? 600.75. So I'll get on after the fact, manually kind of change that so that I can get rid of question 3. So don't worry about it until I'll have it fixed probably sometime this afternoon. But this is how we'll try to use these Canvas quizzes from here on out. That way, we hopefully won't run into Wi-Fi issues. It looks like that we have with Top Hat.
Well, the quiz always be good.
Will the quiz always be what?
You did.
Yeah, it likely won't because the due date hasn't passed. It'll once we're out of class and I go back in, you'll be able to go back and review the quiz questions that we did in class. Yep. Okay. All right. And so actually then what I will likely do, well, 4 minutes. I know I have it set to be 9, so it'll expire here in 4 minutes. That's generally how we'll do this. All right. Any other questions related to that before we keep moving here? Yeah. Yeah, so what would, if I asked you instead, this is a good question. Might show up on like a quiz or something, right? If I asked you for the opportunity cost of 1 gun, what would you do? The inverse of what? The slope. So 1 over 3/4 or 1 over 0.75 would be 4/3 or what? 1.33 repeated, right? Now, I likely wouldn't use those numbers on a Canvas quiz because then I have to go in and like 1.33 accept margins of error. I usually try to get so it's 1 exact value, so there's no, issue about how we get entered in. Yep. Okay. All right. Any questions on that before we keep moving here? Okay. All right. So let's go back to the slides here. Where did we leave off? So I can tell you guys are eager to get out of here. We still have 15 minutes of class. If I start cutting class short, that means you guys aren't going to start doing as well on quizzes and things like that. So we've still got some material to cover. So bear with me. Hold on for a second. All right. All right. So we're going to keep running with this exact same example. All right. We've got India. We've got the US. We have the exact same numbers. So we have the exact same costs, right? In terms of how much they can produce of each one of these goods if they're using all the resources. Now, this also goes to show sometimes I'll use these Canvas quizzes at the very end. Sometimes I'll use them even earlier than we did today. Like maybe I'll start class with them, maybe do a little review or something like that. So that's why getting to class on time is important. So here we've got our costs for both countries, right? We're going to start to think about, could there be gains from trade? Okay. Well, let's think about India. So if they're thinking about how much does it cost India to produce an aircraft part? We said it cost them 2 iPhones, and it cost the US 2 iPhones, cost India 5, right? So we're thinking about trading. How many iPhones would India be willing to give to the US for 1 aircraft part? Well, if they produce it themselves, they'd have to give up 5 iPhones, right? So if I'm trading with the US for 1 more aircraft part, I'm better off if I give them any amount less than 5, right? So as long as the US is okay with this, I can actually say trade away 4 aircraft parts, 4 iPhones, get an aircraft part from the US, and I'm better off than if I had given up 5 iPhones myself. So India would be better off if, for example, the terms of trade for an aircraft part were 4 iPhones, okay? So anything less than their cost, right? Now, how many iPhones would the US be willing to accept? Well, if the US gave up an aircraft part, right, they're trading 1 away. Well, if they were to just stop producing it themselves, how many iPhones would they get back? Each aircraft part, if they stop producing it, they could get 2. So as long as India is willing to give them more than 2, the US is okay with this terms of trade as well. So what would our range of values that make sense for our terms of trade of one aircraft part be? Anything between 2 and 5, or, right? I think, do I have it here? No, I'm going to write it out for us then. All right, so here we've got our terms of trade will really be anything between 2 and 5, because we said the US is okay for giving up an aircraft part as long as they get more than 2 iPhones for it. India's okay getting an aircraft part as long as they only have to give up fewer than 5, because those were their own costs. So really, when we're thinking about terms of trade, say for this aircraft part, really what is that to be more general? So this was our terms of trade for one aircraft part. Whatever the cost, the lower cost country's cost was, so lower cost country's cost was, and whatever the higher cost country's cost was, as long as there's our terms of trade is somewhere in that range, both parties will be okay trading. So our lower cost was what? 2 iPhones, that was the US. And then our higher cost was the 5 iPhones, which was India, which is why kind of our terms of trade for one aircraft part was anywhere in between. So I used the value of 4, right? What would another value be that both countries would be okay with? As long as one aircraft part was traded for 3 iPhones, 3.5, 2.5, 2.1, 4.99, right? Anything, anywhere in between, right? Now, we're just identifying in this class that there is a range of possible values that would make sense. Then we could like go to the next step, which is, what does India want that terms of trade to be closer to? It's a little tricky. So when they're trading for an aircraft part, what do they want to do? Give up fewer. So what do they want that terms of trade to be close to? The US is cost of 2. What does the US want that terms of trade to be? Well, if they're giving up an aircraft part, they want it to be closer to getting 5 back. So then we have like some, this is where countries kind of come in stalemate. We talk about like the issues that exist with bargaining. We're not doing that right now in this class. We're just identifying that there is this range of values where we could come to an agreement, where both parties are going to be better off. Remember, something we talked about last week, we make decisions out of self-interested, rational, selfish individuals. This meets that criteria. If we can come to a terms of trade somewhere in this range, both parties would be better off trading as opposed to just producing it themselves. Okay? Any questions on this before we keep moving here? Yeah. Yeah, so they will technically always be on the left-hand side, but really to build our terms of trade, we're going to need the cost for both, right? So yeah, generally whoever can do it at the lower cost, the way that we write things out mathematically, right? Their cost will then always be on the left. If we write it out in terms of like greater than. Yep. Just kind of foreshadow a little bit. I could work through the numbers again and think through this, looking at it. But if I know the costs here to one more aircraft part, what would my terms of trade for one iPhone be? Well, it follows the same format. Who has the lower cost? What country has the lower cost, and what is it? Well, if we know the costs for an iPhone, how could we find the cost of, we knew the cost of an aircraft part. How could we find the cost of an iPhone? Well, for the US, that would simply be 1 over their cost of an aircraft part, right? Or 1 over the cost of the other goods. So that was 1/2, right? What about for India? Well, their cost was 5, so 1 over 5, that was 0.2, right? Now this is the cost of an iPhone, so this is how many aircraft parts we were giving up. So who has the lower cost to iPhone production, or who has the comparative advantage? We said it was India, so similar thing. Who has the lower cost? Who has the comparative advantage? This would be kind of India's cost of 0.2 aircraft parts. And who has the higher cost? This would be the US's 0.5. So the terms of trade for an iPhone is basically anything in between the costs of this other good for the two countries. Notice, it's just like when we were going from the slope represented cost for the x-axis good, and if we wanted the cost for the y-axis good, we have to do 1 over that. If I find the terms of trade for the x-axis good, how do I find the terms of trade for my y-axis good? Well, I would do 1 over both of these. The only thing that gets a little bit tricky is if I were to do that, then I would have like, it would look something like that. So just in terms of how we have to write it, we would like want to flip everything, right? Now you could write it this way. It's saying the same thing, right? It's just generally the way that we would read this and write this is going from lowest to smallest, but you could write it this way. Mathematically, it's saying the exact same thing. So once you find the terms of trade for one good, you automatically know the terms of trade for the other good is the exact same thing, just like we were doing before. It's just 1 over those costs. Okay. Any questions on this before we keep moving here? Okay. So I think I've got something in the slides that might make this a little bit easier too. So you can think about it this way. Maybe here's a different way of thinking about it, right? You could, instead of like jumping right from, oh, terms of trade for an iPhone to terms of trade for an aircraft part, let's just start out like we hadn't talked about terms of trade yet. We said that what, the US, how many aircraft parts would they be willing to give up for an iPhone? Well, if they produce it themselves, right? When they were producing one iPhone, it cost them half an aircraft. So if they were to trade away an iPhone, they would want to make sure that they're trading it away for something lower than what it cost them. So they'd be willing to give up an iPhone if it cost them anything less than their own cost, which was 0.5. Okay? So they're okay as long as that terms of trade is below 0.5. What about India? Well, their cost was 0.2. So if they want to trade away aircraft parts, right, to get one more iPhone, well, if they did it themselves, they were going to have to give up 0.2 aircraft parts to get one more iPhone. So as long as they're getting back something that's greater than 0.2, then they're okay with that terms of trade, right? So same kind of idea. We say, okay, if India's okay taking anything above their cost of 0.2, the US is okay with trading away anything that's lower than their own cost of 0.5. There's going to be some range of values that makes sense. Okay. Any questions on this before we keep moving here? Let me see, where are we at in terms of, well, we've got 7 minutes. I think we can do this. So we've got this set up, right? And we already talked about, what do we notice about the terms of trade? It's just 1 over the cost of the other good. We kind of already talked about that. Now, we're doing a very simple 2-country model here. So it'll never be the case where we don't have a range that makes sense. If we have a multi-country or multi-firm or whatever it is model, you actually can end up with a scenario where maybe for certain goods, there's no like overlap, right, in our costs. Although like here, I mean, even though there might not be a large overlap, it's always going to be that these two costs, someone, to the point earlier, is going to have a slightly lower cost. So even though the terms of trade might be a very small range of values, we should still in these models always have some range where we could come to an agreement where there's a trade value that both of us would be okay with, right? That would make both of us better off than if we were just to produce this good on our own, okay? So we can prove this to ourselves, right? So let's assume that we have no trade, right? Now I came up with these values, and we might be able to hammer them a little bit more next class, how I come up with them. I did a little bit earlier how we could find different points on that production possibilities curve, but I'll focus more on that next class. But let's say I chose one of those points on each country's production possibilities curve. So the US, using all their resources, could produce 20 iPhones and 5 aircraft parts. That was one of the points on their curve. That was India. So I'm gonna mix it up. India could produce 20 iPhones, 5 aircraft parts. The US, a point on their curve was 15 iPhones, 22.5 aircraft parts. Okay. So this was no trade. What's the kind of total that we would have, right? Well, the total aircraft parts in the world, if there's only 2 countries, would be what, 27.5 here? What would the total iPhones be? We have what, 40? So 40 and 27.5 was kind of like our worldwide production. Okay. What if, where would it be after trade? So let's say that the 2 countries, we already set this example up, that they were okay if the terms of trade for 1 aircraft part was anything in between, I think it was 2 and 5 iPhones. So let's say they agreed on the number of 3. Every aircraft part when we trade is going to be worth 3 iPhones. So if we start out and say, okay, the US says we'll give up 5 aircraft parts at this terms of trade, which means that we should be getting back 15 iPhones from India. Okay. So India is going to produce these 15 iPhones. They're then going to trade them to the US for 5 aircraft parts. Now, part of this terms of trade is going to be, so where are we kind of starting out? Let's assume that we are able to trade. Each country is going to do what they have the comparative advantage in. Okay? So we said the US has the comparative advantage in aircraft part production. So they're going to use all their resources to produce aircraft parts, which if I remember right, going all the way back was 30. Right? India is going to produce what they have a comparative advantage in, which was only produce iPhones. If we then agree to trade, I think the numbers that I had here was the US said, okay, look, we'll give you 5 aircraft parts, right? So, but in return, right, we want 15, right? Because each aircraft part was worth 3 iPhones. We're going to get 15 of your iPhones. So India is going to give up 15 of their iPhones. But what are they going to get back from the US? 5 aircraft parts. So after trade, we had the US would have what? 25 aircraft parts and 15 iPhones. India would have what? 35 aircraft parts, not aircraft parts, sorry. 35 iPhones and 5 aircraft parts. Right? So, oh, and you can't see anything I'm doing because I accidentally switched this. Hold on. Stop me if I do that, if I'm writing up here and I think I hit the button. Sometimes it's a little sensitive. So once again, let's start out. Both countries are only producing what they have a comparative advantage in. Okay. They then say, okay, look, we're going to give away 5 aircraft parts to India if they give us 15 iPhones back, because the cost in terms of trade was 3. Every aircraft part was worth 3 iPhones. The India is giving up 15 iPhones to get 5 aircraft parts. So the new kind of total that each country would have will be 25 and 15, and then 35 and 5. Right? So this is just a quick snapshot. If we do allow trade, we get 25, 15, 35, and 5, which compared to our pre-trade numbers, notice what's true about the US. Well, they still end up with 15 iPhones, but they now have more aircraft parts. And India ends up with the same number of aircraft parts after trade, but they have more iPhones. So this is just a quick, easy kind of set of numbers that shows if we trade at any value in that terms of trade, and we could do this for 3, 4, anything in between 2 and 5 there, we'll end up with numbers that are higher after trade for both individuals, which if trade makes both individuals better off, the self-interested rational thing to do would be to trade, right? So this is why we see countries like, specialize in production of certain goods and then trade with other countries, because it ends up with both of them being better off. Okay. All right. So I went right up to 9:15. So you guys get out of here, stay warm, pick up on this next class. I'll see you on Thursday.
Very much, man.
Yeah. Thanks for the good question.